Hello everyone. Let us study the next type and the next concept that is nothing but types of precipitation. Okay, so the different types of precipitation are cyclonic precipitation, convective precipitation, orographic precipitation, and turbulent precipitation. Okay, so first is the cyclonic precipitation. So in cyclonic precipitation, we have two types. That is, one is called as the non-frontal cyclonic precipitation, and the other is frontal cyclonic precipitation. Okay, so in cyclonic, basically, now this how this precipitation happens is for the precipitation to occur, that is for the rainfall to occur, it is nothing but there will be a cooling of large masses of moist air. So lifting of these air masses to a higher altitude on a larger scale, it on a larger scale happens through a cooling process. Now, these precipitations are based on the mechanism which causes lifting of air masses. So precipitation is nothing but lifting of the air masses. Now, how it is lifted and in what way, at what temperature, what height is again categorized into the four types. So first is the cyclonic precipitation. So cyclonic precipitation, again, this in this we have two types. So basically, cyclonic precipitation is nothing but it is associated with cyclones or moving masses of air that involves the presence of low pressures areas. So and now the cyclonic precipitation is divided into non-frontal cyclonic precipitation and frontal cyclonic precipitation. So in this non frontal cyclonic precipitation, in this what happens is the low pressure area is developed it will be developed. And now this low pressure, now basically low pressure area is nothing but it is a region where the atmospheric pressure is lower than the surrounding pressure. So here the atmosphere, so low pressure area is nothing but where the atmosphere pressure is lower than that of the surrounding areas. So now this low pressure area, the air from this low pressure area converges laterally. You can see here it will converges. This is warm air. Hmm? Okay, so this is the cool air. So the air from the surrounding, it converges laterally towards the low pressure area, and hence what happens, this warm air, it gets lifted up. Hmm? Lifting of the air, and when it gets lifted up it cools, and this may result in the precipitation. So the warm air gets lifted up from the low pressure area, and it cools, and then it forms a precipitation. The same thing frontal, so this is non-frontal. This frontal precipitation, cyclonic precipitation, is nothing but basically front means it's a barrier region. Front means it is a like a barrier region between the air, two air masses having different temperature, densities, moisture content, etc. Okay, so now uh, if a warm and a moist air mass, if a warm and moist air mass, it moves upward, and the mass of cold and heavy air masses, uh, so the warm air move upwards, that is over the mass of cold air, that is cold and heavier air masses. The warm air gets lifted, cooled, and then it forms the precipitation. Same thing like this. So such a precipitation is known as warm front precipitation. The warm air gets lifted up here, okay, then it becomes cool, and then it falls back to the ground in the form of precipitation. So this is called as cyclonic precipitation. Okay. Next is non convective precipitation. So convective precipitation is due to the lifting of warm air which is lighter than that of the surroundings. Generally this type of precipitation occurs in the tropics, where on a hot day the ground surface gets heated unequally, causing the warm air to lift up, and the precipitation occurs in the form of high intensity and short duration. So basically, the surface is not it doesn't get heated equally throughout. So because of this difference in the uneven heating of the land surface, so the warm air it gets lifted up, and that's why it will have high intensity. The rainfall will be high. Rainfall intensity will be high, but it will be for a short duration. Okay. All right. The next one is orographic precipitation. So you can see here in this picture, orographic precipitation. So now this is the most important precipitation because it is the responsible. It is responsible for most of the heavy rains in India. So, orographic precipitation, it is caused by air masses which strike some natural topographic barrier. So basically here it is striking the hill mountain. Okay, it's striking the mountain, and that's why it cannot move forward because it's striking the mountain. It cannot move forward, and that's why what happens? It rises here, and here only it condenses. It cools and condenses and falls back to the ground in the form of precipitation. Okay, so the greatest amount of precipitation falls on the windward side and leeward side is very little. So you can see here the wind blows here. So this is called windward because it, it strikes the mountain here and falls back to the this part of the surface. So this is called windward side, and the opposite where it doesn't get rainfall, doesn't move ahead. So this is called as leeward side, and the leeward side has very little precipitation. Okay. Next is turbulent precipitation. So turbulent precipitation is nothing but it is basically the combination of several above cooling mechanisms. So the name itself said it's a turbulent. So there are many combination of many such mechanisms, and the change in the frictional resistance as warm and moist air moves from ocean onto the land surface. So there is a frictional resistance because the warm and moist air from the oceans moves onto the land surface, may cause lifting of air masses, and hence precipitation due to, and thus it precipitate due to cooling of this. This precipitation causes very heavy rainfall. That's why it's called as a turbulent precipitation. Okay. Okay, the next one is forms of precipitation. So the different forms of precipitation are, so you can see here, of course, I've named extra here. This drizzling, rainfall, snow, hail, glaze, sleet, frost, and dew. You can see here. So dew is very mild, whereas mist is all within the atmosphere only. The atmosphere is not clear. It looks very opaque. Okay, in this mist, you can see here, and this is fog. Okay, which is very opaque and you cannot see ahead. And this is the rain, which you've already seen. And these are hailstones. Hailstones are stones of the ice. And finally, this is the snow. Okay, so let us study this one by one. So if you've seen drizzle. Now, drizzle is basically a precipitation which consists of water droplet, which is again of the diameter less than, the water droplets are of diameter less than 0.05 centimeter, and which has an intensity of less than 0.01 centimeter per hour. So in this, drops are so small that they appear uh, to flow in the air. So that's why we call it as very drizzling. Okay, it's very minute and very slow. Okay, and but you can actually feel the rain. Okay, that is called as a drizzle. Next is rainfall. This is again another form of precipitation, wherein the droplets are now quite larger than 0.05 centimeter diameter and up to 0.6 centimeter diameter. Water droplets which are of size greater than 0.6 centimeter, that is of diameter, they tend to break up. Okay, they tend to break up easily as they fall into the atmosphere. And of course, the intensity varies from 0.05 centimeter to, that is 0. Centimeter per hour to 0.075 centimeter per hour. Okay, so again, there are different types here. Again, it is, if you categorize rainfall, there is light rainfall, moderate rainfall, heavy rainfall. Okay, based on the intensity of the rainfall. Okay, so next one is the snow. So again, this precipitation is in the form of ice crystals. So these crystals are usually, they carry a very thin coating of liquid water and forms large flakes when they collide with each other. So these liquid flakes, when they collide each other, they become bigger and they end up forming a snow. Okay, next is the hailstones. So hailstones are nothing but these are the precipitation in the form of balls, and they are irregular diameter. And again, the main important thing is diameter is basically quite bigger. That is 5 mm or more. Okay, so next is glaze. Now the glaze, it's also called as freezing rain. So in this, the ice coating formed from a drizzle or rainfall, it comes in contact with very old objects in the ground. It occurs when the cold layer of air with temperature below 0 degree. Now this will happen only in the temperature where there is below 0 degree Celsius. Okay. Next, sleet. Sleet is a precipitation. No, next, sleet. This is sleet. It's a precipitation in the form of melting snow. So, whichever the snow melts, so there it ends up in sleet. So, it is a mixture of snow and rain. Mm. It is in the form of pellet again, and they are sometimes also called as small hailstones because of the diameter is lesser than 5 mm. It ranges from 1 mm to 4 mm, so they're called as small hailstones. Next, frost. It's a form of precipitation. Next, frost is a form of precipitation which occur in the form of scales or needles or feathers of ants. So they're very thin. Hmm? They're very thin, and they're flaky, and they are formed in the form of scales. And the last one is dew. Okay, this is dew, and this is a form of precipitation which does not occur because of condensation in the high layer of atmosphere, but it is formed by condensation directly on the ground. So usually this dew occurs in the night when the ground surface is cooled by outgoing radiations. So it is mainly because of condensation of condensation is happening directly on the ground, not in the atmosphere. Okay. All right. So that's all for today. Thank you.